This is the video lesson for image formation in plane mirrors. The learning target for this lesson is, I am learning to identify the law of reflection and to apply it in analyzing image formation in plane mirrors. The test criteria for this lesson are, I can identify the law of reflection, I can determine the location and characteristics of the reflected image, I can determine if the reflected image is real or unreal, and I can draw ray diagrams for plane mirrors. So let's talk for a minute about reflection. So light reflects off of reflective surfaces. So this is how we see everything that we see in the world around us is either light emanates from that object, so the sun or a light bulb or a fluorescent lighting, the light is emanating from that object, or light is reflecting off of it, and that light then is coming to our eyes. So all wavelengths of light reflect except for gamma rays. So gamma rays are the only wavelengths of light that don't reflect. X-rays reflect differently than visible light or infrared or ultraviolet light, but everything reflects light except for gamma rays. Gamma rays, the wavelengths are just too small to be able to reflect light, but everything else reflects light. But in this class, we're only going to talk about visible light. So we're only going to talk about the visible wavelengths of light. All right, let's talk about the law of reflection. So the law of reflection says that the angle of incidence is equal to the angle of reflection. So theta I, which is the angle of incidence, is equal to theta R, which is the angle of reflection. So in this, we're talking about relative to the normal or the perpendicular line. So relative to normal or perpendicular, this is true. Okay, so let's look at this little video here, little animation. So here we have the object and the image. The incident light, the incident ray reflects off of the mirror and hits your eye, and that creates a place for the image to show up. So we have the reflected ray, a straight line from the reflected ray determines where the image is placed. And the incident angle and the reflective angle are the same. So we have the object here, we have the image, and the line from the reflected ray goes straight through the mirror to the image. And notice that the two angles are identical. All right, now let's talk about the location of the reflected image. So we have the object here, and we have our reflected image here. So D0 is equal to DI or DO. The distance of the object from the mirror is equal to DI, which is the distance to the image. So DO is the distance from the mirror to the object, and DI is the distance from the plane of the mirror to the image. So if you're trying to find the location of the reflected image, it's always going to be opposite the object, and the distance is going to be the same. So however far the object is from the mirror, that's how far the image is going to be from the plane of the mirror. So what about the characteristics of the reflected image? What are interesting what information about the reflected image do we know about a plane mirror? So do we have a real image or a virtual image from a plane mirror? And how do we know? So we have a virtual image created by a plane mirror, and a virtual image is an image that does not have any light passing through it. No light passing through it. So the image in a plane mirror is virtual because there's no light reaching the reflected image because it's behind the mirror. So no light ever reaches the reflected image because it's behind a mirror, so there's no light actually getting to the reflected image. We also know that the reflected image is left-right reversed. So you can see here in this diagram, the reflected image is backwards from the objects. And we know this when we look in the mirror, when we raise our right hand, it looks like we're raising our left hand in the image. And further, the image in the mirror, in a plane mirror, is upright, meaning it's not inverted. It's not upside down. We'll see in different lenses and curved mirrors that sometimes the image is inverted rather than upright. All right, now we're going to look at some examples on how to draw ray diagrams for plane mirrors. So a ray diagram gives us the opportunity to see where the image for an object is going to be versus in relation to where a person is that's seeing the object in the mirror. So you can tell how much of an object you're able to see in a mirror depending on where a person is related to the object. And it's very helpful to just be able to determine where things are going to be located in mirrors. So the way we start is we draw a line from the eye to one end of the image. So first we start with a mirror. So we have the mirror here. We draw where the eye, or where the person that's seeing is, located. So we have the eye here. We have the object. So we've drawn an object. And we place the image exactly across from the object, the same distance from the mirror as the object is. Then we're going to draw a line from the eye to the image. All right, there's our line from the eye to the image. Now we draw from the mirror back to the object. We draw a line. Now this is the incident ray from the object to the eye. So this is the incident. So this is incident, and this is the reflected ray. Now we're just going to draw the next ray to the other extreme edge. We draw this one to the other extreme edge of the object. So now we have two incident rays and two reflected rays. And we can see now, based on the line of sight, where the image is located in this mirror. All right, we got a second example here to draw a ray diagram for this object here. And here's the image. Here's our mirror. And here's our eye. So the first thing we're going to do is draw a ray from the eye to the image. I like to draw a dotted line past the mirror to the image. This signifies that there's no light making it past the mirror to the image. And then we draw a line from where the ray from the eye to the image hits the mirror. We draw that reflected ray. There we go. So this is our incident line. This is our incident ray, and this is our reflected ray. And then we draw the next line. This is always best to do with a ruler if you can get a hold of one. All right, so this is the incident ray and this is the reflected ray. Now, notice that we're not measuring any of these angles. We just, by drawing the diagram, we are drawing the correct angles here. So the incident angle and the reflected angle are going to be correct just by drawing the ray diagram correct. So this is the incident angle and this is the reflected angle. Keep asking questions, everyone. It's how you learn new things.